Welcome to the Ask Tom for January 2020, everyone. We can't believe we're saying January 2020, but my name is Richard Evans. I'm an outbound product manager of Oracle Database Security. So I cover your encryption, your privilege control, your auditing, your monitoring, your masking, all those things. And I have my friend and coworker here, Peter Wahl, the product manager of Advanced Security and Key Vault, and he's going to take us through a demo on TDE and Key Vault today with DataGuard. All right, so just so you know, this call is being recorded, and we'll make this available afterwards at asktom.oracle.com. If you haven't been here before, AskTom is a direct channel into Oracle Database Security product development and product management. You can ask questions at the end. You can send us emails. You can make suggestions. So we like to take topics and whatever you want to talk about, we build on it. There's 2 of these that are held on the second Thursday of every month. We try to hit both sides of the globe. And they're identical, so you only need to attend one. All right, we'll do some announcements, and we'll try to keep it quick since I messed up on a couple minutes there. Oracle Data Safe, if you haven't tried it out yet, our cloud-based security solution, check it out. It has a couple new additions there with automatic target registration for your autonomous databases. And then coming in the next week or so, we've got support for federated logins. Right now, you have to create a local Oracle Cloud login. That works for most customers. Some other customers, they say, no, we use federated. So you're going to have that support here in the next week or so. All right, a product update. Peter is happy to announce that we have released Oracle Key Vault 18.2. And so as you can see here, we've got a lot of new features with it. And for more information, go check out that What's New section in the Oracle Key Vault Administrator's Guide. All right, 18.2 just came out. We're really excited about that. And then there's a certificate out there now for database security. So if you are an Oracle certified professional and you want to concentrate on database security, there's a certificate available from Oracle University now for that. So check out education.oracle.com for more information on that. And then we're just going to start and kind of level set with some support notes. When you're working with Transparent Data Encryption, 2 MyOracle support notes that you should be aware of are this master note 1228046.1. That's the master note for TDE. And the quick TDE setup and frequently asked questions doc is 1251597.1. And that's kind of a basic how-to for getting up and running with TDE in simple use cases. All right. All right, let's jump right into our technical session. I'm going to describe it, and then Peter's going to talk you through it, okay? So what we're doing today is we are going to use a single instance multi-tenant DataGuard implementation on Oracle Database Enterprise Edition 12.201. Peter's patched this environment to the October 19 RU and applied an additional patch set, which he'll mention why in the conversation. He's using a 2-node a 2-node read-write pair of Oracle Key Vault. He's using 18.1. That's because we did this right before the release of 18.2, but the same functionality is there in 18.1 or 18.2. It's just when we recorded the video. First thing we're going to do is just the basics with TDE, setting up that wallet and doing TDE, encrypting an existing table space, that user's table space. Then we're going to switch roles and do ReKey operations so you can see DataGuard and ReKey and how they work together. We're going to tag those PDB, that pluggable database keys, using the administer key management command. So look for that. That's something that's available in 12.1 or higher with that admin key management syntax. He's going to install the Oracle Key Vault client software using RESTful APIs. This is super powerful because if you're doing this on more than one database, if you're doing this on 800 databases, 1,500 databases, or even 80 databases, right? You want to take advantage of RESTful APIs and what we can do with Key Vault there. It's going to get that key uploaded into Key Vault, migrate it from the wallet to OKV, and eventually delete that local wallet file, and then show you what those ReKey operations and switchovers look like when we do that in an online master key mode using Transparent Data Encryption and Oracle Key Vault 18. All right, let me bring up the video. We recorded a video for this because we do a couple switchovers and because we do reboots here, and so we cut that time out. So, Peter, do you want me to drive still, or can you click the drive button, the play button, do you think?
No, I can't. This
Oh, that's right. That thing's
other, yeah, it's still covered with the operation commands for the web conference.
all right. So I actually enjoy driving, so it works out well. So Peter, over to you, sir.
Okay, good. So I hope everybody can understand me well. So what we see here is the top window is our primary database. The lower window is the standby database. You can see that after I started the database, I automatically query a view that tells me what role that database has. So as I said, the top one is the primary, and the lower window is my standby database. So in order to set up TDE, we need to create the directory first, which I'm doing here in the standby first. It doesn't matter where you create this directory first, but we do it in the standby. And oh, that was quick. So we create the directory, and we also make changes to AskTom so that our database knows where to find that that wallet that contains the encryption, the TDE master encryption key. And now we do the same thing on the primary database. So we create a directory as root, we change ownership to Oracle, and then we reduce the access permissions. That's all what I do here. You see, I take it down to 700. And then the next step is to change the AskTom and add the encryption wallet location thing to it. Yep. Since we are in a single instance, since we are in a single instance environment, we don't have to restart those databases. Single instance databases read AskTom whenever you log into your database. A RAC database doesn't do that. Grid infrastructure ignores the environment variables intentionally, so your RAC database doesn't know that you changed AskTom. A RAC database needs a restart if you change AskTom before you can do this. So we already created our key store in the primary database. The next step would be to open that key store. And we open it for the root container and for the pluggable database, right? So it's open for both. And now we create our first key, but this is only a key in the root container. I could do for the set key operation, I could do a container equals all. That would create 2 keys. But as we see in the next command, after I log into my pluggable database, I do a set key operation, but I tag the key, right? We mentioned this earlier, so we add a tag to it. That allows me later, when we uploaded those keys into OKV, I can very easily find keys that belong to that PDB. That doesn't really buy you much in this case where I only have 1 PDB, but if you have an Exadata system with 100 PDBs and each of them has its own keys, you would be glad you tagged your keys. So now we close your key store, we create an auto-open key store, and now we copy those 2 wallets, the password-protected wallet and the backups and the auto-open wallet, everything, the whole tree, into to the standby database. And now in the standby database, we have to open the key store to load those keys into database memory. Mm-hmm. So that's already our TDE setup. So if you work with wallets, we can stop that video now. We are basically done. That's how easy it is.
Yeah.
And now we can start encrypting. So we're using a new feature that was introduced in 12.2 where we can encrypt table spaces online, right? So we do this without downtime. Your application so far hasn't suffered any downtime. Mm-hmm. Right? So this is all good. So we encrypted the user's table space in the root container, and now we do the same thing in the pluggable database. Same thing. So we encrypt the user's table space. And now I would show you something. When we initially set the first key 2 minutes ago, the MRP didn't stop because your database didn't contain any encrypted data. You need to understand that when you do a set key, we not only create a key in the wallet, we also update a table in the system table space. And that update gets shipped over to the standby database, but the standby database doesn't have the wallet yet, right? We haven't copied the new key over. So in this case, if you have encrypted data in your database, your MRP will stop. And that when we initially set the key, in the very first moment, there was no encrypted data, so that update to the system tablespace was held back in the standby database. And only when you encrypt data, that change is applied. The standby database loads the key and can encrypt tablespaces. Now, when we create a key, that is one half of the set key command. So we split the set key into create key and use key. So now here you can see that we create a key for the PDB, and again that has a tag. So, and we exit from the PDB and we create a key for the container database. There we don't need a tag. We are not so much interested because there's only one container. We know that all keys that don't have a tag are the container keys. Okay, so now we copy those new keys that are in the wallet but not used by the database over to the standby database. Open the key store one more time so that the standby database loads those keys. And then we log into our root container and do a use key command. Now that means that now the root container has activated that key and uses that key. And that update is then shipped over to the standby. The standby database finds the key in the wallet and everything is good. Right? So we do the same thing in the root container and in the pluggable database. Both of them use the key that they created a minute earlier. And as you can see, the MRP didn't stop. Right? You see that in the alert log window in the lower half, there is nothing, the MRP didn't stop. Now, a DBA will tell me, well, if I have one standby database, that doesn't really bother me if I have to open the wallet and restart the MRP on my standby database. Fine, but you can connect up to 30 standby databases to one primary database. And that is when this becomes a little annoying if you have to go and open and have to open multiple standby databases and open the key store, restart MRP, have the standby databases catch up to the changes and all these things. So here we did the ReKey operation without interrupting anything. So what else did we do? The next step is that after we use that new key, we will go ahead and change a system setting in, oh yes, we copied the changed wallets over to the standby again, not because the key material has changed, but both commands, both use key commands have the backup clause. So we created two new backups just to be on the safe side, and we want always the wallets and the keys always to be the same on primary and standby. Mm-hmm. So that new setting that we just applied, the set encrypt new table spaces equals always. That is something that we inherited from our promise in the Oracle Cloud that always that everything is always encrypted. So if you have an application that you install into your database, that application most likely doesn't have the encryption syntax. Right? If you install a PeopleSoft application in your database, they don't know if you have TDE enabled. If you do have TDE enabled and you set this parameter, then all the table spaces that will be created by the installation script of your application will be automatically encrypted. Right? So there's nothing that you have to do afterwards. Your table spaces are encrypted as they are created, even if the encryption syntax is not given. So we now changed the primary and the standby database to both encrypt new table spaces, and now we create a table space in our pluggable database without providing any encryption syntax. So as you can see in the alert log of the primary, it's encrypted with AES-128. And also in the alert log of the standby database, we can see that this table space was created, and here we confirm that yes, indeed, we have two encrypted table spaces in our PDB, the user's table space and the protected _fin PDB. Now we create a table in the encrypted table space. And when you use the method to create encrypted table spaces by default, we use AES-128. From a security perspective, most people will tell you that AES-128 is has a higher security than AES-256. One reason for that argument is that AES-128 has fewer rounds where you could theoretically inject something, but most security policies in our accounts that we talk to about TDE, they have a policy that dictates to use AES-256. Okay, so let's then rekey that key to AES-256. This can be done online, again, without downtime. And to confirm that everything is working, we select from the encrypted table space. So everything is working. We exit, and in the standby database, we log in to DataGuard Broker and do a switch over so that the database in the top window will be our new standby database, and the standby in the bottom window will be the primary. And I believe that is one of the points where Rich shortened the video. I've never seen such a quick switchover.
Fantastic. It's 17 exadatas behind the scenes.
Yeah, exactly. They're all in my garage. They're my demo machines. Okay, so unfortunately, there is a little bug in TDE. And even though we copied the auto-open key stores into that standby node, we still have to open the key store, and we only have to do that for the PDB. So somehow the PDB doesn't auto-open the key store. We need to do that manually, and then we can select from our encrypted table, right? So that's all good. And now we like to verify that TDE is also working in the other direction. So the create a tagged key, again, it's create key. On our new primary, we exit and we create a key in our container database. So those keys are not used by the database. They're only inserted into the wallet. We exit. We copy all the wallets over to our new standby database. Oops, there we go. And then we have to go back to our standby database, and that's the same bug as it is on the primary. Even though we have an auto-open wallet, we need to open it manually, unfortunately. Okay, so now we can go back to our primary database, log into the root container, and do a use key command. Again, the same thing as before. We're just validating that TDE is working in both directions.
Yeah, this use key is so powerful to me. I think the create and use is a fantastic thing. So if you don't take anything away from it today, I think create or use is great for these environments. It really is.
Yes. Okay, that again created backups of our wallets, even though we didn't really make any changes, but still we copy everything over so that we do proper householding. Okay, now we go back to our current standby database and do another role switch so that we get to the same situation that we started from. After we did that role switch, which again is unbelievably fast, if you could quickly halt the video, please. That demo was born out of a customer request. It's a large bank that is implementing OKV, and they will connect something between 8,000 and 12,000 databases to OKV. They have a security operations team. That security operations team has access to the Oracle account on all database servers. That's where they install Tripwire and Guardium and all these third-party tools to lock down those databases and to monitor everything that the DBAs and the application users are doing. So what they asked me to show them is, so let's think it's Friday evening, the DBAs go home, and over the weekend, the security operations team will migrate those databases into OKV. That's one thing. The other thing is they want the DBAs not to be able to use an OKV to download to basically download the keys of that database and walk away. So what we need to do is we need to lock down that access to OKV. And so there are a few things that we have to do while we migrate that database to OKV. We will also implement separation of duties so that the DBAs don't have access into OKV, but still can do ReKey operation, and they can use TDE, but they cannot make configuration changes. They cannot log into OKV and do things. So after we switched over and we log into our pluggable database on the primary side, we will see that we can automatically select from our encrypted table. So there we don't have that bug that we had after our first switch over where we needed to open the wallet. Here we have a functioning auto-open key store, and that's one thing that makes it so complicated for my developers to find that bug, because sometimes it happens, sometimes it doesn't. So now let's pretend that the DBAs went home, and now we are the security operations team. We logged into our DataGuard databases. We verified that the Java version is up to date because we need that. We also verified that we have a soft link that points from user bin Java into the Java of that installation that we have. And now we will download a file that was created by the OKB administrator. We create a directory that will hold the OKB client installation. That's the first thing. The next part is that we download a set of files that were prepared by the OKB administrators. All databases download a similar or equal file to this what we have here. So you see for the primary database, we have an extra file, OKB deploy primary.tgz. And once we download this file to the primary database, we will unpack that file, and I will show you what's in that package. So we log into our file server, we downloaded that file, and then we do the same thing on the standby database where we download a file called OKB deploy standby. That's a little bit different. I will show you the differences very soon. And now that we unpacked both, I believe that we will go to the primary database first and talk about what we have there. So in this file, we found a configuration file. The configuration file tells the database where to reach OKV. That's the IP address in the first line. Then we have a user in OKV that I called REST admin. That's a user that the RESTful API uses to log into OKV. In OKV, that user needs to have the system privilege, the system administrator privilege, and the key administrator privileges, because some of the commands that the RESTful API will execute require either the system administrator privilege or the key administrator privilege. The next two lines define where we log and how fine-grained we log. And then the last line says client wallet equals home Oracle. So the client wallet are the two wallets that were packaged into this file. So if you look at the line after we unpacked this tar file, you can see an ewallet.p12 and the cwallet.sso. Those two wallets contain the password for the REST admin user. Theoretically, the configuration file for the REST admin, for the RESTful API allows you to specify a password, but who on this planet wants to put a clear text password in a configuration file, right? Nobody. So we put this password for the REST admin user into an auto-open wallet. And the OKV administrators who create those files, they know the OKV, they know the password of the REST admin user because they created that user in OKV. Mm-hmm. Right? The DBAs don't know that password, right? Or nobody who runs that RESTful API needs to know that password. Mm-hmm. There's also the second last line of that configuration file says script equals home Oracle script.txt. Well, there is no script. The point is that every DBA will download that same script, that same package. And so we need to individualize script.txt needs to be different for every DBA. We have a file called runme, and if we run runme, then we will create script.txt. And now we have it. So you can be as creative as you want. We need to create a wallet in OKV. That wallet is shared by primary and standby database. So I give it, in my case, I give it the Oracle SID as my wallet name. The endpoint names are different. There are two endpoints. There is one endpoint for my primary database. There's one endpoint for my standby database. And so I call the endpoint name is constructed on Oracle SID on short hostname. Then we have a type as Oracle database. The operating system is Linux. And then the free text is again the long host name and my IP address of that server. That free text will be visible in the OKV web GUI. So you could potentially add the DBA's name to this, or the DBA's telephone number, which means that if the key administrator ever needs to contact the DBA because something needs to be discussed in regards to TDE and key management on that database, the key administrator can easily find by looking up the host name in some corporate directory. Maybe it says that that host name is managed by a DBA called Peter, and here's the telephone number. So the DBA can easily contact the DBA. The next command is set default wallet. That is very, very important because we need to associate the endpoint with the wallet. We need to grant access to the wallet, to that endpoint. And then the provision command downloads and installs the OKV client in the directory that we created a few minutes earlier. Now, if you go into the lower window, you will see it's very similar. The endpoint name is different, right? Because the endpoint name is different. It's now, again, the Oracle SID on hostname. That's, of course, a different hostname now that we are on the standby database. And that script doesn't create a wallet, right? You see a create wallet command in the primary database, but you don't see a create wallet command in your standby database. What we do is the set default wallet command on the standby database associates that second endpoint with the same wallet, which means primary and standby database have access to the same keys that are stored in that wallet. And then we do a provision command on the standby database, and that installs the OKV client. So now we can go ahead and run the OKV RESTful service on the primary first, because we need to have that wallet. So now we created a wallet in OKV. Usually we call it a virtual wallet. We create an endpoint for the primary database. We provision, download, and install the OKV client. And we do the same thing on the standby database, except we don't create a wallet, we already have one. Okay, so we install the OKV client on the standby database, that's all good. And while that installs on the standby database, we validate that the installation was correct. So can you stop for a moment, please? In the middle of the screen for the primary database, we see that command where I use name_i, which is a program that follows soft links. I use name_i to validate that the Oracle installer added a soft link that points to the OKV client installation. Because when we installed the OKV client, that happened outside of the database. The database doesn't know that we installed the OKV client. It happened on the operating system level. So how do we know, or how do we enable the database to find that client software? Because in a minute or so, we will expect the database to talk to OKV, right? So at one point, the database needs to find that. And by adding that soft link in a known directory that points to the installation directory, that's how the database finds the OKV client installation. And then the next step that we execute as root, we deploy the PKCS11 library into a fixed directory where the database automatically finds it. That's a long-standing standard in Oracle. There are other components of the database that put libraries into that directory. Okay, so the installation of the OKV client on the primary side is done, and now we run the root script on the standby database. Okay, so now if we go check into OKV, you will see that we have our wallet, and that's still pending, but that doesn't really matter. It only says that the replication to my second OKV cluster isn't done. That's why this is pending. But you see that I have granted access to this wallet to my 2 endpoints, right? And if we click on the Endpoints tab, okay, click on the Endpoints tab, we see our 2 pending endpoints, and we see that both endpoints have the shared wallet as their default wallet. This is super important. So the set default wallet, or if you do it via the web interface, you can do that manually. If you don't define a default wallet, then your databases can create keys because they find the endpoint, but your keys are stored in OKV without being associated with a container, which is that wallet. Again, if you have only one database, who cares? If you have a container database with 100 PDBs and all of them create their keys without a container, you will have a very hard time keeping them separate. So you always want that container to be defined for your endpoints. Okay, so those 3 elements, the wallet and the endpoints, were created by the RESTful API in OKV. When we downloaded the package in the provision command, you could see that all databases initially have used the same password, change on install, when they download and establish the connection into OKV. That doesn't really make sense. So as the security operations team, in the absence of the DBA, we changed that password to something that the DBA doesn't know, right? So the default password is change on install, and then we come up with a new password that only the security administration or the SecOps team knows, and we will change the OKV password, the password that you need to interact with OKV from that database, to something the DBA doesn't know. And we do that on the standby database and on the primary and on the standby database. Okay, the next part is, this will happen on the primary database, we will upload the keys from the wallet into OKV. And that is something unique to OKV. You cannot do this with an HSM. An HSM doesn't allow keys from the outside to be fed into the HSM, right? HSMs are very strict. And so if you migrate your database to an HSM, you still have your wallet lying around. And if you look at the new version of the PCI standard, it clearly tells you no encryption keys on your database servers. So yes, you have used an HSM and it's very secure, but your PCI auditors will still complain about a wallet being on your server, and you need this wallet for older backups. So now we upload those keys into OKV before we migrate. So they are now uploaded. The next step is we will change the password of the TDE wallet so that the DBA doesn't know that anymore, right? So the only thing that the security operations team needs to know from the DBA before they go home on Fridays is, what is your wallet password? And most likely they will have to give it, and we will change that wallet password to something that the DBA doesn't know. Now we add the OKV password into our TDE wallet. That gives us an auto-open connection into OKV. So, okay, so we made changes to the wallet. We changed the wallet password, and we added the OKV password into our TDE wallet, which means we need to copy those wallets again over to the standby database And in the standby database, we log in and we open the key store with the new password that the DBA, who is in his weekend right now, doesn't know. So if we go, okay, so yes, we add the password. Yep. So that's the next step is a new feature. You see that we add another wallet into a new directory. So this goes into the same directory where basically where the TDE wallet is, but there is a new subdirectory called TDE_SCPS. And you also know that usually wallets always appear in pairs, right? If you have an auto-open wallet, there's always a password-protected wallet and an auto-open wallet associated with it. A new feature in Oracle 12.2 allows us to create only an auto-open wallet, all by itself. And this is even a local auto-open wallet that doesn't open on other machines. And this auto-open wallet will contain, again, the OKB password, and that is inserted into this other wallet. And the reason why we do this is we want to hide the OKB password from the administer key management commands. When you install the OKB client, it prompts you for a password. That password was the same for all DBAs who download that script. We changed that OKB password to GR120KB, and that password goes into two places. It goes into the OKB util command. So if you download the wallet, if you do an OKB util list, you need to give that password, but we don't want the DBA to know that password. On the other hand, that password goes into the administer key management command. So if the DBA wants to do a ReKey operation, he needs to do administer key management, a set key identified by that password. So we need to tell the password to the DBA, but we don't want him to know that. So inserting the OKB password into that new auto-open wallet takes care of that problem. The next command will tell the database in which directory we find this external key store credential location. And that's a static parameter, which means we need to bounce that database at one point. Before we do that, we will change the SQLnet.aura to point to OKB. Okay, so now the SQLnet.aura is changed to OKB, and we will shut down our primary database. That's the only bounce that we need. So now while this is going down, we make the same change to our standby database. We add this new auto-open wallet into the TDE_SCPS subdirectory. And we tell the database where to find this wallet, right, by setting the static parameter. Okay, we do this, and then we bounce, or we make changes to SQLnet.aura so that it points to OKB, and then we bounce our standby database after that. All right, so that's again one of the things that Richard shortened in the video, so that's a very fast bounce.
That's right.
Okay, while the database is restart, we can take a look what we have done in OKB. We uploaded the wallet, right? So we can basically filter by creation time, and here we can see all the keys that we uploaded from that wallet into OKB, and we can also clearly identify the keys that belong to the PDB, right? Again, it doesn't have very much institutional value. If you have only one PDB, you know, oh yeah, that's my PDB. But if you have an Exadata system with 100 PDBs, you would be glad if you tagged them, because then you can identify the keys that belong to those PDBs very easily. Okay, so meanwhile, our standby database is back, and now we restart our primary database.
I should have made that one a little faster.
Yeah. Okay, so I think before this database comes up, we do an OKB util list on the standby database. That should be coming up very soon, if I remember correctly.
Yeah, I think you're right.
Yes. Okay, OKV utilist. Again, our DBA doesn't know that password, so he can never do it. And there we see the same keys that we saw in OKV, right? We see our three keys that belong to the root container, and we see 3 keys that belong to our PDB. Okay, so at one point, the primary should come up. Okay, there we go. And we do an OKV utilist as well, meaning both primary and standby database see the same key material because the endpoints share the same wallet. So now we migrate. Now we tell our database to no longer create keys in the wallet. We now do everything online with OKV. And the MRP doesn't stop because the standby database has the same connection into OKV. It sees the same keys. The MRP doesn't stop. So all this without downtime. The only downtime was because we needed a bounce because of the static parameter. Everything else, no downtime. So now we see two new keys in OKV, right? The 2 keys that start with 06, those are new keys in OKV. One of them belongs to our PDB, and we always want PDB keys to be tagged. So let's log into our PDB and add a tag to the correct key. So for this, we have the administer key management set tag command that will extract the key ID that belongs to the FIN PDB from a view and will associate a tag with the correct key ID. Okay. Okay, so this was done before we do the set key command. And now what am I doing there? Okay, okay, I'm exiting. I do the same query on my primary database. I still see those 2 new keys. And now I will log into my primary pluggable database and run the set tag command to replace the key ID, which doesn't give me much, with a tag that is more declarative in OKV. Okay, so now I'm adding this tag to my key. And if I do an OKV utilist again, then I finally see this is my new PDB key that has just done this new tag. And it's the first key for that pluggable database in OKV. So that's why that tag looks a little bit different than the other ones. But still, it allows me to find that key. Because I have an auto-open connection into OKV, I can select from my encrypted tablespace, and now I can do set key. I no longer need to separate that out into create key and use key. I can do set key operations because as the updated key ID is shipped over to the standby database finds that new key in OKV. So there's no MRP that goes down. If I remember correctly, we didn't need to restart the MRP a single time, even though we did a lot of experiments with TDE, but the MRP never went down.
Yeah. And you don't have the password there anymore either.
Exactly. We replaced the password with external store. That comes from that new system parameter. Mm-hmm. So that means our DBA can do AKM commands that do not modify the TDE setting, right? He couldn't do a reverse migration because reverse migrations require the password. We needed the password. We needed both passwords to migrate to the wallet. So to change TDE configurations, passwords are needed. To use TDE, no password needed. Our DBA can do ReKey operations all day without knowing the OKB password. And he cannot do OKV downloads because he doesn't know the OKV password. He cannot download the wallet and walk away with the keys, right? That was the condition that my customer wanted to see. So now we do a role switch again, just to confirm that everything is working. Now the primary database is the bottom window. We do a select from our encrypted table space. We have an auto-open connection into OKV. That works immediately. We can do a set key operation the other way around by doing that on our, oh no, I bring my own key. That's another thing. So OKV supports bring your own key for maybe 2 years already. We started this in 12.2.06. That's an 18.1 cluster. So we started doing this 2 years ago. I don't really understand where the fascination about bring your own key comes from. Because if you don't do it right, bring your own key can generate a pre-breached key, because humans can see, modify, mess around with this key. So I could go into the text file and make that key all zeros, right? All zeros has the same randomness as any other random string. So OKV wouldn't complain, but I would know the key, right? So only if you do this with separation of duties, this makes sense. And that is why I'm doing this on my current standby database. That doesn't need to be done on your standby database, but that's the only one that I had with me right now. You can do that on any machine that has connection to OKV. So if I'm the key administrator, I can create this text file, and if you continue the video, we built a command that automatically uploads that text file into OKV with a tag again, right? So this is my upload command. I upload into a certain wallet a text file, and I upload this into OKV. So I'm the key administrator, and I upload that text file into OKV. My next step is that I take the key ID and email that key ID to my DBA. Now the key ID, we learned that earlier, the key ID needs to have 06, so we know that's a key in OKV. And I can send that key ID to my DBA, and the DBA can say, use key with that key ID. And then we did a ReKey operation to that key that the key administrator uploaded into OKV. So sometimes cloud customers are a little bit concerned about where keys come from, right? That gives you a certain sense of ownership, right? I have my databases on somebody else's computer. I have my encryption keys on somebody else's computer. So at least I want to own the keys. I'm the cloud customer. I want that cloud service to use my keys, right? If you have OKV, then we allow you to do this. But it makes only sense if you do it with separation of duties, where the key administrator uploads the key and then only gives the key ID to the administrator, and then the administrator uses that key ID.
Mm-hmm. It doesn't know the password at all there because of that identifier.
Yeah, again, we don't know, the DBA doesn't know the OKV password. And we can still select from our encrypted table space. And so ReKey operations are transparent. Switch overs are transparent. I would say that this pair of DataGuard databases behaves the same way it would behave without TDE. And that's the goal.
Mm-hmm.
Because it's called Transparent Data Encryption. You shouldn't see it. And whatever you do, role switches, I mean, we can do way more things. We can do a snapshot standby. We can do all those things. And TDE will no longer be visible, or will get into your way. Let's put it this way.
Yeah. Yeah, that's powerful stuff, Peter. I think that taking customers from that basic wallet setup, like you said, hey, if you've got a single instance with no data guard, no rack, really no complexity, you showed them how to set up that wallet-based TDE, and then you introduce that complexity that most customers have. Not a lot, right? But data guard is its own animal, And so you have to account for that when you come with data guard and multi-tenant and transparent data encryption. So again, this was today's scenario. This is everything we went through. We are going to do another one of these. I think we're talking about doing it next month, February 13th, 2020. So that'll be our next Ask Tom session. So we're open to suggestions, but we're thinking about doing TDE Advanced Use Cases Part 2 with real application clusters. So doing kind of the same demonstration, but with RAC instead of data guard this time. And as always, we're using Tim Hall's scripts, his Vagrant scripts, to do this behind the scenes. So Tim hopped on and joined us here for a few minutes. And Tim, we appreciate all your hard work on that Vagrant GitHub site and making that possible for us to do these demonstrations super easy. So if you haven't checked out Tim Hall's scripts, please check them out. Tim, you can put the link there in the chat. I don't have it open, I'm sorry. But he's got data guard scripts, he's got rack scripts, and Peter, you're a believer as I am.
Oh yeah, totally.
So we've got a couple minutes, well, actually about 3 for questions. Feel free to unmute yourself or say something in the Zoom. Do you have any questions for Peter? There's the script, github.com/oraclebase/vagrant. Yeah, it's good stuff.
I have a question actually, Peter. So let's say you're a customer that is transitioning to OKV, and then for some reason, whatever that reason is, you want to come out of it. Would that be a sensible time to consider using your own keys and upload them so that you have the option of coming back easy? Or is there a way of kind of migrating off using the keys that are generated?
If you migrate out of OKV, and that's, thank you for asking that question, because that's another thing that you only can do with OKV. If you migrate out of OKV for whatever reason, like, I don't know, hardware failure, something happened, you want to get out of OKV for whatever reason, you would, instead of uploading the wallet, you would first download the wallet into your file system again, so that you have all your keys that belong to your container and all the PDBs, and then you reverse migrate, where you tell the database, no longer talk to OKV, talk to the local wallet again. Mm-hmm. And it doesn't matter where the keys come from. The keys can come from the database, from OKV. You can upload your own keys. Starting from Oracle Database 18, we also allow you to bring your own keys into the local wallet. So there the process is a little bit more involved, but it's not as easy as it is with OKV. But in 18, you can also not upload a text file into the wallet, but you can use a set key command with a special syntax that basically allows you to specify a random generated key ID and a random generated key, and then use that key or set that key, right, depending on how we do that. Maybe if the next sessions that we do with REC could be a 19.5 REC or maybe an 18.8 REC, I don't know what I will be using, and then I could add that we can add bring your own key into the local wallet. Mm-hmm. But it doesn't matter where the keys come from when you like to reverse migrate out of OKV. And you cannot reverse migrate out of an HSM. If you reverse migrate out of an HSM, that's possible. TDE allows you to do that. But you would only create a new key in your local wallet. Because a migrate operation is always a ReKey operation. So you create a new key that goes into your wallet, and all your old keys are still in the HSM. So if you have a backup from before that reverse migration, you need to keep that HSM around, even though you migrated out of the HSM. Hmm. Okay, but if you really hate OKV, you can download the wallet, migrate out of OKV, and nuke all your OKV servers, and you're good.
Yeah, I mean, the question's really more, and I know that the point is a bit flawed, but people always seem to get sort of caught up in lock-in. And people always want a sort of backout plan.
Mhm.
And so that's the only reason for raising it. It's not that I expect someone to say, oh no, what have we done? It's really just people wanting to know that there is a route backwards as well as forwards.
Yeah.
Yes, yes, definitely. There is a way out of OKV, yes.
Yep. All right. Any other questions? I'm keeping you a little bit past the hour here. We got a little late start. My apologies for that.
I have one more.
Okay.
If you do the next one, will I see the bits I missed on this one in terms of the earlier setup bits?
Yeah. I mean, the basic setup is it's the same for the most part. If you do rec, there are a few extra gymnastics that we do, but yes, it's the same thing. I don't when you joined, but I think it was before we migrated, right?
Yeah.
Okay, you will be fine. You will be fine.
And this video will be available on asktom.oracle.com a couple days after this session. So if you want to go back and catch those first 5 or so minutes, then you're good. So, yeah, another question here.
Hi, I have one question. My name is Ravi. So regarding this PDB keys, what if we have a scenario today? I deployed a new tenant, so I created a new PDB. So for that, I have to create a new key.
Yes.
And tomorrow, if I drop the same PDB, like a container, and reuse the same container for another new PDB, how does these keys work?
Okay, so if you create a new PDB in your container, you would like to encrypt table spaces in that new PDB, you need to open the wallet for that PDB, right? Or you need to open the connection to OKV. Maybe not, because we have an auto-open connection. Then you can do a set key operation with container equals current. That creates a key for that PDB in OKV. And if you tag that key, then we know that this key belongs to your new PDB, right? And if you nuke that PDB because, well, because you can easily identify the keys in OKV that belonged to that PDB, and you can delete them if you want. You can leave them there. We don't need them anymore because the database doesn't exist. You can do whatever you like with those keys, but be careful not to delete the wrong keys. Again, that's a thing where the tagging is really helpful, because you know, okay, I have the PDB number 5 that I don't need today. I created it yesterday. Today I will delete it, and then you can delete all the keys that belong to PDB number 5. And then tomorrow, if you create PDB number 6, that's completely independent from what you did yesterday.
And Peter, Key Vault makes that really easy, right? It's a little more difficult if you're doing it wallet-based. Is that a true statement?
It's true when you clone PDBs.
Okay.
Right? When you clone a PDB with OKV, a clone firmly believes that it's the original. That's the nature of a clone, right? So after you clone a PDB, that PDB wants to use that same key that the source of the clone created. And if you do this with a wallet, you have to export the key that belongs to your source database. While you are logged into the source database, you export that key from the wallet into a text file. And then you log into your cloned PDB and you import that same key into the wallet, but with a different identifier, because now you're logged into the clone. In OKV, we have a shortcut. We allow you to, we do a special import key command that has been tuned, and I have to say, it looks like a hack, but it works. We do an import key with 2 blank statements that allows you to give the new key ID of that cloned PDB to the key that already exists in OKV. And from that moment on, you're good. So that's, again, greatly simplified if you clone a PDB and those PDBs are connected to OKV.
Yeah, great question.
Okay. Adding to that, One more question regarding in the same lines. So as we speak, as you said, we have 6 containers today, and tomorrow I'm going to drop a third container, like a PDB number 3.
Yeah.
And so the OKV still exists those container keys, right? And later, if I have to create a new container, it is going to reuse that container 3, which was dropped earlier. It won't create a container 7, right? And when it reuses that same third container, and after that PDB is created, I have to again set a key. How does this wallet handles that same container with a new PDB and a new key, having existing keys?
Yeah, so that's not a problem, because OKV would only complain when you upload a key that already exists, because OKV doesn't allow key collisions. We don't allow a key to be coming into OKV from wherever it comes from if it already exists. It's not the key ID that we complain about, it's the key itself, right? Now, if you delete a pluggable database and you leave the keys and you leave the endpoint, so that when you bring that same PDB fresh with the same name back into your container, we will be reusing that endpoint. So that database only needs to open the connection into OKV if you don't have an auto-open connection, and it will establish the connection through the existing endpoint. And then if you do a set key operation, that database doesn't have an updated system table space. It doesn't know anything about TDE. So what you can do is you can either tell the database to use one of the existing keys, or you can do a set key operation and create new keys.
Okay. I remember we were hitting this as a bug in version 12 in the past. So just curious, after that, I was not have a hands-on like with the new version, how it behaves. So just curious. Thank you.
Of course.
Feel free to reach out to us through email. My boss's email is on the screen, russ.lowenthal. He can direct it to Peter. He can direct it to me. We can, if you're still having issues, let us know. And, you know, if you have ideas for another one of these deep dives into TDE, let us know that too, so we can get some of these questions answered for you.
Thank you so much.
Yeah, thanks for attending. Is already recording this session, I believe. Is that correct, Russ?
We're recording now.
All right. All right. Hello, everyone, and welcome to Oracle Database Security Office Hours for January 2020. That's pretty neat to say. This month's topic is on Oracle Transparent Data Encryption. This is a first of what we hope will be several sessions on Transparent Data Encryption advanced use cases. TDE is one of the most deployed database security features, and it's also one of the easiest to deploy. In most cases, using TDE is simple and straightforward, but there are use cases in complex environments that can trip a customer up or give them some questions. So in this series, we hope to kind of cover some of those more complex use cases and give you some background information you need to make your deployment successful. So my name is Richard Evans. I'm a product manager here at Oracle, covering Oracle Database Security. I'm joined today by my colleague and friend, Peter Wahl, who's our product manager for Advanced Security and Oracle Key Vault. All right, just a reminder, this call is being recorded, and that recording for this will, and all past sessions for AskTom are available on the AskTom website. Just click all sessions to previous months to view those recordings. And just to level set you, AskTom is a direct channel into us, Oracle Database Security product development and product management. It's intended for us to have a free and open forum to discuss questions that you can't get answered elsewhere. Each session will start with some relevant product announcements, some technical content, and then some extended technical questions and answers. And I think we'll have quite a bit of that today with Peter's session. So now remember, we can't really help you with service requests on here. contact us offline. Please work through your service request number that you have. And we run this session twice a day on the second Thursday of each month. These are identical sessions. You don't need to attend both, but we do this to try to make this session available to everyone around the world. All right, let's kick it off with some announcements. Every month we mention Oracle Data Safe, but that's because it's a new and fantastic product that's maturing quickly. Unlike on-premises products, Data Safe updates happen every 2 weeks or so, and we don't publish the versioning schema there. So we're just going to talk about a couple of recent changes that we have. So in this recent update, we've made it easier for autonomous databases to be registered with Data Safe. Now it's enabled through the Autonomous Database Console, and there's a procedure to grant additional privileges to your system. So if you're using Oracle Data Safe and you're looking at Autonomous Database, please go out there and look at that dashboard, look at how easy it is to register and to connect with Oracle Data Safe. And if you need to grant some additional privileges, take a look at the documentation, because there's this procedure, DS target util, to grant role, to grant some of those finer privileges that you might want to grant on your database. Second, we're updating Oracle Data Safe to support federated logins sometime in the next week or so. So this removes that requirement to create local cloud logins in order to provision or access Data Safe. So this is one of the changes, couple of the changes that we're really excited about that have been implemented in Oracle Data Safe or are quickly coming in Oracle Data Safe. And one that's relevant today is an update to Oracle Key Vault. So just around Christmas time, we released Oracle Key Vault 18.2, and there's some significant new functionality in there for one of our fastest growing products. Key Vault is a fantastic product. Peter Wahl's going to cover it today. He's going to use Oracle Key Vault in his demonstration. So some of the additions you see here include console management certificate rotation. So you can regenerate and rotate that OKV server certificate and associated endpoint certificates from that console. We've got improved security for OKV admins by removing their ability to change another admin's password there. Instead, it'll select a randomly generated one-time password. We've got improved HSM integration. The auto-expiring persistent cache is now available there and protected by an automatically generated password, and so much more. So please take time to take a look at that What's New section of the Key Vault Administrator's Guide for full details. All right, so in late November or so, Oracle University released a certificate specific to Oracle Database Security. We had the opportunity to help with this certificate, and the topics are wide and deep. It's a fantastic certification. So if you are an Oracle Database Administrator, an OCP already, and you're looking to focus more on database security, please take a look at this certificate. Those topics include, typical attack points, some basic regulatory requirements, understanding those CVEs or patches, deploying the maximum security architecture. We have previous videos where we've talked about the maximum security architecture. And so please, we cover that in the certification, auditing, monitoring, managing, network and transparent data encryption. So you'll learn some today that'll help you with the certificate, and data redaction, masking, vault, all sorts of things. Basically, it's a very robust certificate that we're offering. So please take a look at education.oracle.com for more information on that. So for today's topic, there's a couple of MyOracle support notes that you may want to take a look at as you deploy and manage transparent data encryption. So the first one, take a look at the master note for transparent data encryption, that doc ID there on the screen, 1228046.1. So use this as your index for relevant notes and information on TDE. We try to work with Oracle support, and Oracle support looks at the SRs, and if they see that there's a need to update this document, they try to do so frequently. So this should be your first stop if you have questions or concerns on TDE besides just the Oracle documentation. And the other one is this quick TDE setup and frequently asked questions. That's doc ID 1251597.1. It's a basic how-to guide for getting up and running with TDE in a simple use case. Okay. All right, so we're gonna jump in here in just a second on our technical session for the day, Oracle Transparent Data Encryption, Advanced Use Cases. I'm gonna give you kind of an overview of TDE and what we're doing today before I turn it over to Peter. All right, so what is transparent data encryption? All right, transparent data encryption encrypts data at rest, whether it's in table spaces, your recovery manager, your RMAN backups, or your data pump exports. It's transparent data encryption because it is transparent to the applications. There's no application changes there. There's minimal performance impact to the applications or the existing queries. And it really is, especially in 12C, Release 2, 18, and 19, very easy to encrypt an existing Oracle database. And then Peter's going to combine transparent data encryption with Oracle Key Vault. So what is Oracle Key Vault? Oracle Key Vault is the only enterprise-grade key management solution that provides continuous key availability for your TDE-enabled Oracle databases. All right, so what does that mean? That basically means you've got that wallet file out there that contains your master keys for your Oracle database. Key Vault can help you get that off the operating system. It can help you manage it more effectively, and especially in your more complex environments, your Oracle Data Guard, your multi-tenant, your rack environments. Key Vault is a key asset there to help you kind of simplify and sleep well at night, knowing that that master key wallet, that key store is backed up and contained in Oracle Key Vault. All right, so why use TDE? Why use Oracle Key Vault? So use TDE to protect application data from unauthorized access by bypass, right? So rather than someone being able to query this data out of the database files, out of the RMAN backups, out of the data pump exports, we need to encrypt that data at rest. And ultimately, right, most organizations have to comply with some kind of privacy and regulatory requirements. TDE helps you meet those by providing data encryption on your database, on your backups, on your exports. So you have that full lifecycle management and control of knowing that that data is encrypted. Key Vault, again, just helps you, like I said, manage those individual wallets and make sure that you've got a backup of it, provide reports, and make sure that you don't lose those encryption keys. You can't lose those encryption keys. Once you enable transparent data encryption on your database, you need to make sure you're protecting that master key file, that wallet file, okay? All right, so let's do kind of a today's scenario here. Let's see what we have. All right, we're going to start with, Peter's going to start with a single instance, multi-tenant data guard 12201 with the latest patch set, October 2019, and he's applied an additional patch set there that you can see on the screen, the 29530515. It's going to be a 2-node read-write pair of Oracle Key Vault 18.1. We're going to set up the basic wallet-based transparent data encryption. So it would be like you have today. If you're using TDE, you're probably using wallet-based. You haven't migrated to Key Vault. So we're going to start there where most customers will. We're going to encrypt an existing table space. We're going to switch roles with DataGuard, perform ReKey operations. We're going to see a tagging of the PDB keys, and Peter's going to talk about why that's so important to tag these keys when you upload them or when you generate a new key within the database. He's going to install the OKV client software via the REST API, which is really fantastic because that's what our enterprise customers want to see. Is they want to see, hey, look, Rich, Peter, I have 800 databases with TDE. I don't want to do each of these individually. So Peter's going to help you with that. Uploading those keys and migrating into OKV and then getting that wallet file off the operating system. And then again, rekeying and switching roles in DataGuard. Okay, so we can kind of see what's going on there. And then preparing that PDB to be relocated So you can pull only the particular pluggable database keys down into a wallet and kind of work with it there, right? So we've pre-recorded this video because Peter is going to cover a lot. And so we've recorded this to cut out those situations where we have to perform a reboot and that takes a minute or two, or when we perform a switch over and that takes a minute or two. So we've consolidated this into a video, which will be available on AskTom. And Peter's going to have a system available where he can do a demonstration for you at the end of the day too. So, all right, so here's what I'm going to do is stop sharing, and I'm going to open up this video on my screen. All right. Drag this over here. Sorry, let me get this. Peter, are you on with us?
Yes, I'm here.
All right.
Thank you, Rich.
Let me get my screen sharing started again. You know, multiple windows. Where's Zoom at? Where did it hide the little thing at? Aha, I found it. All right. Screen 1 this time. Okay. All right. Can you see my screen again?
Oh, yeah. Perfect.
All right. So I'm going to press play and I'm going to mute and I'm going to turn it over to you, Peter.
Okay. Thank you so much. So what you can see here, I cannot spend too much time. I have to really rush through it because that video is like 40 minutes long and we do a lot of things. So what you can see on the top window is my primary database. On the lower window is my standby database. And in the little terminal windows, you see the alert log. So on the standby database, I just created the directories that will hold the TDE wallet. And if we, okay, so, and I change the privileges. In the next step, I add the TDE settings to the espionage.aura file. And now we go to the primary and do the same thing. So we create the directories, and then we make the proper changes to espionage.aura so that those two databases know where to create the wallet. Okay, so here are the directories. And this will add the entries into espionage.aura. And then the next thing is we can immediately create a wallet, right? The database knows the directory, we create a wallet, and then we open the key store. That's our next step. And then we create our first key, and this key will only be a key for the container database. And you will see in the alert log that, in fact, we are creating a new key. So now we have a key for the container database in our wallet. And now we create an encryption key for the PDB. And that key is tagged. So if you could stop for a moment, Rich.
Yeah.
That statement creates another statement. And you see that the tag says the name of our pluggable database plus a timestamp. You see that that I recorded this video very early in the morning. And so now we have a key in the wallet that has a tag. And that's basically, we will need this later when we will download the keys that belong to that PDB from OKB.
And Peter, that was an advancement in Oracle 12.1, is that correct? The tagging?
Oh no, that's a key vault thing. That's nothing to do, that has nothing to do with the database. No,
but the administered key management, setting that key tag, you could do that in TDE, starting with 12.1.
Yes, starting with a 12.1.
Yeah, and that's really powerful, whether or not you're using Key Vault, but particularly important when you are using Key Vault, as you're going to point out.
Mm-hmm. Exactly. So the next step is that we log out of our pluggable database, go back into the container, we close the wallet, and we create an auto open wallet. If you could stop the video for a moment.
Yeah.
We created a key in our primary database.
Mm-hmm.
Usually what happens is if this database is live and if we have an application running and you have encrypted data in this database and you rekey on your primary, the MRP will stop, right? Because the data is encrypted and the standby database doesn't know that new key. But here we did a set key operation, and as you can see in the lower terminal window on your right side, the MRP didn't stop. Now, why is that? Because we know there is no encrypted data in your database. You're just setting up TDE for the very first time. So we are holding that update in the standby database. We don't tell the database, hey, we set a key, because there is no encrypted data. The standby database don't need a key. So why would we tell the database that it needs one? So can you continue?
Yeah, no, that's a good thing to point out. There's the nuance there, especially in a data guard or a rack environment, that you want to make sure that you are not going to affect that standby database. Yeah.
Yes, exactly. So now if we exit from our database, now we copy the wallets over from the primary database to the standby database. So now the keys are the keys are available to the standby database, and we open the key store on the standby database so that the standby database has the keys. So now that the primary and standby database have a key, we can start encrypting, and we online encrypt the user table space just because we can. And that's online, meaning there is no application downtime while you do that. And if you stop for a moment, Rich,
yeah,
you can see that the standby database did the same thing. So the standby database, that was a transaction that is replayed on the standby database.
Yeah, I don't know if folks can see my mouse, but yeah, I'm trying to mouse over
on
here.
the standby database was also ReKey. That was true for the user table space in the container database, in the root container. And now we are encrypting the users table space in the PDB. And also you can see, if you continue the video, you will see that our PDB also rekeys from nothing to the first key. That is why it has a ReKey operation. And now I will show you a trick on how to do ReKey operation when we have encrypted data in our database, right? So now we have an encrypted user table space in our primary and standby database. So now the standby database needs to know that key. But if we don't operate with key vault, we can, instead of doing a set key operation, what we did earlier, we do a create key operation. What a create key does, can you stop the video, please?
Yeah,
thank you.
No, you're good.
And instead of doing a set key operation, which inserts a new key into the wallet and activates that key for the database, we can split this set key command into two pieces. The first one is a create key command, where we only insert a new key into the wallet, but the key is not activated, right? So now you can continue. And again, we create a key without a tag in our root container, and we created a key with tags in our PDB. That happened before. So now again, we copy the wallets over to the standby. We need to load the new keys into memory in the standby database. And so that was a ReKey operation. The next part is that we will go into our primary database and set, now we will use the key, right? We will extract the key ID from a database view so that we know which key belongs to the container database, which key belongs to the standby, to the pluggable database. And we execute this command, and now we use the key. And as you can see, our MRP at the standby database didn't stop.
Yeah, Peter, what would you normally see there when it does stop? You see a message that says like waiting on something, right?
I believe it will tell you that the managed recovery process has stopped.
Yeah, that's right. Yeah.
Okay, and there was one more thing that I was trying to say. It's maybe not so important if you have only one standby database. If that one MRP dies, you restart it, you're good, right? That's not a big deal. But you can connect up to 30 standby databases to a primary database. And if you have to do that 30 times, that gets annoying.
Yeah, and if you have a large environment too, if you have 800 databases that are using TDE and you're doing a ReKey operation and there's rack and data guard enabled there. This is something I learned from Peter when we did this. Is I wasn't good at using. I always just did the set key, but using the create and the use key is a really fantastic method of doing this.
Yes, it is. So now on our primary database, you see that we do an alter system set encrypt new table spaces equals always. This is a setting that we inherited from our cloud databases, where all table spaces are always encrypted. But we backported this so you can use it in your on-premise database. If you create a table space without adding the encryption syntax, we still encrypt it. It will be forcefully encrypted by using the AES-128 algorithm. And so now we set this, and we set this on the primary and on the standby database. Right, if you let the video run, then I do the same thing on the standby database, so that also the standby database encrypts keys encrypts table spaces by default. And now we log in to our pluggable database, and we create a table space without specifying the encryption syntax. Right? So can you stop the video, please?
Yeah.
You see in the top alert log that we created an encrypted table space. It's encrypted with AES-128, and the standby database did the same thing. So that table space is also encrypted. It doesn't say it, but we will find this in a moment. And yeah, because in our standby database, we will, if you continue the video, we will query a couple views to find out which table spaces are encrypted in the standby database, and you see that the table space that we created in our primary database has already been created on the standby database. So now we create a table in the encrypted table space, and because most customers asked, hey, we would like to encrypt with AES-256, but the default online encryption only encrypts with AES-128, I rekeyed that table space. Can you stop the video real quick, please? Yep. We rekeyed that table space to AES-256. You see that in the alert log of our primary database. And again, that action has also been replayed on the standby database. So both table spaces in primary and standby are now encrypted with AES-256. And now to prove that this is transparent, we select from our encrypted table and everything is good.
Yeah.
So the next step is in our standby databases, we log in as the data guard broker, and we do a switchover.
Yeah. And this is where we cut a little bit of time off our demo, which is why we're doing the video instead of live. Peter could do all this live and he could talk for hours, and it would be fantastic to hear it. Like I enjoy it, but hey, we cut out a little bit of section there, got some time back by.
Okay, stop, please. Unfortunately, there is a bug in the database. We have created auto open wallets, but they don't work all the time. The auto open wallet was open for the container database, but we have to manually open the key store in our pluggable database. That's the next command. So please continue. Okay, so now that we opened our key store in the new primary, which is now on the which is now in the bottom window, we can select from our encrypted table. And just to confirm everything is working, we create another key now on the new primary database. We create a key for the PDB with the tag We log out, we create the key in the container database without a tag because it's not so important. And then we copy the wallets over to our new standby database. So that's the new key in our root container. We exit, and then we copy the wallets over to the standby database.
It's very similar to what we did earlier, right?
Yes, exactly. It's only to confirm that even after a role switch, everything works fine.
Yeah.
Okay, so now, unfortunately, again, we have to go into our standby database and open the key store, even though we have an auto open wallet, but that's the same problem that we had before. And now we go into our primary database and activate that key, right? Again, we search for the key ID, for the right one, and then we use that key. We do this in the root database, in the root container, and we do the same thing in the pluggable database. Okay, so this is all working, and now we log in our standby database. We log in with yes, we copy the wallets over one more time, of course, so that all the backups are there. And now we log in to DataGuard Broker on our standby database and switch back to what we had before. And again, I think that Richard cut out the wait time.
Mm-hmm.
Oh, yeah, that was quick.
Yeah.
Okay, and now the nice surprise is that here we don't need to open the wallet. If you select from a table, we can immediately do this. So here the auto open wallet works as expected, and everything is good. So now if you could please stop the video for a moment.
Yeah.
The scenario that I go through, because now we will be installing the OKV client. This demo was born out of a customer request where the security operations team has access to the Oracle account in all database servers. And they install, maintain security software, Tripwire, and God knows what they install on the database servers. And that is why the security operations team has access into the Oracle account on your database servers. So the use case that they explained to me was, let's think that our DBAs go home on Friday evening and we install OKV over the weekend. And what they want is they don't want the database administrators have any access into OKV, right? Mm-hmm. And so we can do this. And the only thing that the security operations team needs from the DBA is the existing wallet password, right? Because we will be changing that password later. And we need to know that password because we need to upload the keys into OKV before we migrate. The DBAs need to tell the wallet password to the security operations team. Okay, so if we now continue, we need to verify that the operating system is properly set up. We need the right Java version installed, and we need to verify this on the primary and on the standby database. We need a soft link. Yeah, that's Java home. So we use the Java version that comes with the database. That's new enough. And we need to verify that we have a link, that we have a soft link that points from user bin Java into the Java version that we're using. And this has to be existing on both primary and standby. Now we create a directory that will hold the OKV client installation. And we talked about using the RESTful API. So can you stop real quick? Again, yeah. Sorry. So the RESTful API allows you basically unattended mass deployments of the OKV clients on your database servers. The way that we do this is the OKV administrators create a set of scripts and files and all these things. We will go through this in detail in a short moment. And the DBAs, or in this case, the security operations team, downloads that package into the database server, right? So here we We access a file server and we download a specifically created tar file for the OKV deploy for a primary database. And once we have authenticated, we will download that package, so you can continue now. Okay, so we downloaded this package. We're downloading this package onto our primary database. And we do the same thing on our standby database, where the package has a slightly different name. It's for the standby database, right? OKV deploy standby. Again, password to the file server, the file is downloaded, and then we extract all the files that we need that are in this package that is created and prepared by the OKV administrators. And we will now investigate what's in those files. So the first file is the config.ini. The configuration file tells the OKV client software where to reach the OKV server. That's the IP address. We need a user in OKV. That user has a name. In this case, it's REST admin, because it's the RESTful API that connects into OKV. That's REST admin. REST admin in OKV needs to be a user that has the system privileges, the system administrator privilege, and the key administrator privilege in OKV, because some of the commands that we execute via the RESTful API require the system administrator privilege, and other commands require the key administrator privilege. So that is why that REST admin user has both. The next two lines tell us where the log files are and the log level. And then we have a client wallet, and that points to the directory where I extracted this tar file. The configuration file has a user entry, right? The user equals REST admin. The configuration file also allows you to add the password of that REST admin user into the configuration file. But since this is a security product, we don't really want clear text passwords in configuration files. So what the OKV administrators did is they put the password of the REST admin user into an auto open wallet. And you see that we have a ewallet.p12 and cwallet.sso. That wallet contains the password of the REST admin user. And then we have one more line that says script equals home oracle script.txt. If you look in our extracted files, you don't see a script file. But we extracted a file called runme. And if you continue real quick, if you continue the video, please, then we run the runme script. And the runme script creates the script that will be executed by the RESTful API. Because all DBAs download the same script. But we need individual names for wallets, we need individual names for endpoints and all these things. So that is why we have a runme. And here in this example, it goes to the operating system variables for the Oracle SID, for the host name. And that is what I use to construct, to build all these names. So at first we create a wallet in OKV, and then we create an endpoint. And then we associate that endpoint with the wallet. That's the third command. It says set default wallet. That is where we give the endpoint, which represents our database, access into the virtual wallet that we created in OKV. And then the last command, provision, -v is the OKV password. -e is the endpoint name, and -o is the installation directory that we created 2 minutes ago. So what the provision command does, it downloads and installs the OKV client. So if you continue the video, I believe that we go and run, yes. So now we go in our standby database. The configuration file looks exactly the same. But if you look at the script that was created by runme, you see that this is one line shorter. We don't create a wallet. So the create wallet command in the primary database is missing in the standby database. Why is that? Because that wallet will be shared by the primary database and the standby database. So in the set default wallet command in the standby database, you see that we associate the standby endpoint with the same wallet that we associated the primary database with, right? So the set default wallet has the same wallet but different endpoints. And then the rest is the same. It's again a provision command. So now we run the RESTful services. We need to give the configuration file. We create the wallet in OKV. The next is we create the endpoint. We associate the default wallet. We download the OKV client and we install the OKV client. One more thing that we have to do. Yeah, we do the same thing on the standby database. And this is all while the database is running. So there's no downtime. All this happens outside of the database. There is no downtime. The application for now is completely, there's no downtime. Okay, so there's one more thing. Because this installation happened, can you stop the video, please? In order for the database to find the OKB client installation, because the RESTful API and everything that we have done so far happened outside of the database. The database has no idea that we just installed the OKV client, but in a few moments we will expect the database to talk to OKV. So somehow the database needs to find that installation directory. And what we did is, you see that the installation directory is Oracle base /product/OKV, and then we have the endpoint name. But we also create a directory that we know exists. So that's Oracle base /OKV /$Oracle SID. And that's a pointer to the installation directory. That's how the database finds the OKV client installation. And what that name I command does, it follows softlink. I find this very convenient. And so now we verified that on our primary database, the OKV client has been installed, and then we run a root script which deploys the PKCS11 library into a hard-coded directory. And so this was on the primary database, and now we do the same thing on the standby database. If we continue the video, we verify that the soft link has been created, so the database will be able to find the OKV client installation, and we run the root script. Okay, so that was the root script, and the OKV client software is installed. So what we have done, can you pause, please?
Yeah.
We created a wallet, right? That was our first command that we did on our primary database. We created a wallet, and that wallet is already, it's still pending because it needs to be replicated to the other OKV instance, but it's usable. And if you continue, please, if you continue the video. So those are that's our wallet. On the right side, you see the two endpoints that we associated with this wallet. And here are the two endpoints. They're also still pending. And you see that the default wallet is set. And this is very important. This is one of the most common mistakes that our customers make. They create endpoints, they create wallet, but they don't make the wallet the default wallet for that endpoint. And if you don't do this, can you please stop the video? That's important. If you don't do this, then you won't even get an error message from your database, because Key Vault will create keys for you, and the database will find those keys because they are addressed by the key ID, but the keys will not be associated with the wallet. Well, you may say, it doesn't matter if I have one database, okay, but what if you have 5,000 databases in OKV and you don't have a wallet? How do you know which key belongs to which database, right? There's no way to do this. And that is why it's so important to always define a default wallet for your endpoints. Okay, you can continue. All right, so everything is good. We went to OKV. We ran the root script. Okay, so now we know that all DBAs download the same script, which also means that they have the same OKB password, right? You you remember the provision command had a password, and that password is always the same for all DBAs who download. So now we changed the wallet password to something a DBA doesn't know. Right? The DBA may have access to a script when they can download it from somewhere, or when the script is still lying around on the server after the OKV client was installed, but we now changed the OKV password to a password that only the security operations team knows, but not the DBAs. And now we already upload the keys from the wallet into OKV. And that is something, can you please stop the video? That's also very important. That's a unique feature of Key Vault, that you can upload your wallet into OKV. If you think about using an HSM to manage your TDE keys, you cannot upload because HSMs don't allow keys to be imported. HSMs only trust their own keys that the HSM creates. You cannot upload anything into an HSM, which means that after you migrate to an HSM, you still have your wallet around with keys that may be needed by a backup from the time before you migrated to the HSM. So those keys cannot be discarded. We need to keep them. And only OKV allows you to upload those keys into OKV. So your keys are not lost. We only relocate them from your local wallet into OKV. So the source wallet is an auto-open wallet, so we didn't need to provide a password. We just hit return, and now it asks us, of course, for the OKV password that we just changed. And the keys are uploaded into OKV. And now the next step is we change the old TDE wallet password. And that is why I told you earlier that the only thing that the security operations team needs to know from the DBAs was the wallet password. So now the wallet password was manager_1, and we set it to something different, which the DBA doesn't know, right? So now we basically locked down the old TDE wallet. And stop, please. Here's another thing that we did. We add, can you scroll back a little bit? Okay, so here we add the OKV password. Remember, we changed the OKV password, right? That was like 2 minutes ago. We changed the OKV password. Now we add this new OKV password into the TDE wallet. Why are we doing this? To get an auto-open connection into OKV. Because it's important that your standby database has an auto-open wallet, right? If there's a failover when your primary database disappears from the network and the standby restarts as a primary database, then you better have an auto-open wallet, because otherwise your new primary doesn't come up. So we always want to have auto-open connections into our local wallets and into OKV. By inserting the OKV password for the client HSM password into our into our TDE wallet, we allow the database an auto-open connection into OKV. And that was that last command. That's also new in 12.1 with the administrator key management, that we can add, modify, and delete secrets into wallets. And that's one use case for such a secret.
Yeah, and Peter, this is really important, like you mentioned earlier, where if you have so many different data guard standby databases, you don't want to go and open each one of those, open the wallet on 36 different data guard standby instances.
Exactly.
Yeah.
Okay, so you may continue. So now we added the OKV password into the wallet. And the next step is, oh yeah, stop please. So the first thing is we changed the wallet password, and we made changes to the wallet password by adding the OKV password into the wallet as a secret. And now we copy that wallet with a new password over to the standby database, and the standby database doesn't know that password. So we need to open the key store in our standby database with the new password, so that the standby database has all the keys, it knows the OKV password, all the information that we put into the wallet needs to be known to the standby database as well. And now we create another directory. Okay, oh, that was a little bit too quick. Oh, I know. Okay, so here's a new feature that contributes, or that makes it possible to separate, to enforce separation, to enforce a separation of duties between DBAs and the key vault. Some of you may know that the OKV password that we changed a couple moments ago, the chia120kv, goes into two places. It goes into the OKV util command. So whenever you interact on the command line with key vault, when you do OKV util list, if you do OKV util upload or download, it will prompt you for the OKV password. And the OKV password also goes into the administer key management commands on your database, where you have to type in that password, right? Administer key management, set key identified by password. So in this case, our DBA needs to know the OKV password because he needs to do ReKey operations maybe. And so we need to tell him the OKV password, and that's something that the customer didn't want. So what we can do, and that's a new feature in 12.2, we can insert, again, the same password as a different client into another standalone auto-open key store. And that goes into a directory called TDE_SCPS for Secure External Password Store. And so now we're inserting the OKV password into another wallet. And this is only to hide the OKV password from the DBAs. And now we need to tell the database where to find this wallet. And that's by this system parameter. This system parameter tells the database, okay, you will find the OKV password in this wallet, in this directory. So that was on our primary database, and we do the same thing, of course, on our standby database. That's next. We opened the key store already, so now we go to our, we make changes to AskTom before we migrate. We change method to OKV, and we reboot our primary database because that auto system set external key store location is a static parameter. So in this case, you need to bounce the database for this change to be picked up. So we shut down our primary database, and while the primary database goes down, we make the same changes to our standby database. So in our standby database, we, what do we do there? So we add the secret into the new auto-open wallet, and then we tell the database where to find this new auto-open wallet that hides the password from the OKV administrator. And that's, again, a static parameter. So in this case, we have to bounce our standby database as well. Okay, so the primary database is down. We make changes to the AskTom, and we bounce our standby database. So standby database goes down, and I'm pretty certain that Rich made that shorter and faster.
Oh yeah, yeah, we cut out a couple minutes there. Yeah.
Okay, and now we go to OKV, and there you can see all the keys that we uploaded. And you can already see the tags that we gave to our PDB keys in the local wallet. So the tags survived the uploading of the keys into OKV. So our standby database is running, and now we start the primary database.
I thought I cut out more time here, but maybe there we go.
Okay, so in our standby database, we do an OKB util list, and I was too lazy to type in the password, so I echoed it into the command. And that lists, again, that shows us the same keys that we were able to see in OKB in the web interface, right? It's the same thing. So it allows us to validate that our database has a functioning connection into OKB. And we see that we have 6 keys, right? We have 6 keys. And now very soon we will be migrating that database to OKB, and then we have 8 keys. Again, we validate that both databases see the same key because both databases share the same wallet. And now we do the migrate command. Right, that's our next command. That's migrate, right? So that will tell the database from now on, we are no longer using the local wallets, we use OKB. And again, in the alert logs, you can see that both primary and standby database follow that procedure and create new keys in OKV. Good. So now we migrated, and now we have 2 new keys, right? One of them belongs to the PDB, the other one belongs to our root container. So now that we have migrated, we need to tag that new key, right? Because we don't know which of those 2 keys belongs to the PDB. And again, we can query and we can give that key a tag. There is a set tag command. And the tag is a little different. It says finPDB first migrate. This is just for me, so I know that this key is the first one that I created in OKV. Right? I have a timestamp on when I migrated approximately. So now I can tag that key. Okay, so I did something twice. Keep going.
All right. Now you're tagging.
Exactly. Yeah.
The PDB key, right?
Yes, exactly.
Yeah, that makes sense. That tagging feature, the admin key management command, is fantastic.
Yep. Okay. So now we have a tag, and if we do an OKV util list again, we will see that the tag has changed, right? There's one key that says finPDB first migrate. And we can select from our encrypted table without opening anything because we have an auto-open wallet. We have an auto-open connection into OKV. What we also can do, we can now do set key operations. We don't need to split this into 2 commands. We can do a set key operation, and you see that we replaced the identified by OKV password is now identified by external store. This comes from the extra wallet that we created in the TDE_SEPS directory. This is how a DBA can interact, can do ReKey operations and everything without knowing the OKV password. Okay, now just to verify everything is working, we do a switch over to the other database. And we log in, and we can select from our encrypted table without opening the key store, because we have an auto-open connection into OKB. And that, by the way, is that extra patch that Rich mentioned in the beginning of the presentation. That patch enables this. So now if we slow down, if you can stop for a moment, I will show you how to bring your own key. Some customers think that this is a really good idea. I have my doubts, because humans can see, modify, play around with this key. But still, we support it. You can bring your own key into OKB. For this, you create a text file that has 2 lines. The first line says TDE master key identifier, and that contains a random 16-byte string that is converted to uppercase. That is what the XXD program, the XXD command -u, creates it, converts all characters to uppercase. And then the next line creates a 32-byte random string. And that text file has only 2 lines. So that this text file is called bring your own key.txt. And so now that we created, we need to build an upload command that, again, has a tag for this key. So this is my OKB util upload command. And again, you see that the comment has our key tag. So that's finPDB with a date stamp. And now we upload that key into OKB. Okay, can you stop, please? This, I think that bring your own key only makes sense when you enforce separation of duties. I do this on the current standby database only to highlight that this can be done on any computer that has the OKV client installed and that has connection into OKV. So a key administrator can constantly create those keys, upload them into OKV, and afterwards we only need to share the key identifier with the DBA, not the key itself. So if you enforce separation of duties while bring your own key, then bring your own key makes sense. Otherwise, I think it's just too dangerous. Okay, so now we uploaded this key into OKV. This can be done from any computer that has access to OKV and has the OKV client installed. And now the key administrator sends the key ID to our DBA, and our DBA inserts that key ID into a use key command, right? And I mistyped. Okay, so let's try this again. And as you can see, the key ID is prepended with 06. 06 tells the database that this key comes from OKV. 01 is a key that comes from a wallet. 06 is a key that comes from OKV. So now we tell the database to use that key that the key administrator generated on some other random computer, and we can still select from our encrypted table space. Okay, so now the next step is that we do another role switch so that we get to our original configuration. And after this, we will select from our encrypted table, and this will again work because we have an auto-open connection into OKV.
Yeah, so we're not copying those wallet files across anymore. We're going directly to Key Vault.
Yes, exactly. So there are no wallets anymore. That's correct. Okay, so I do a set key operation just to verify everything is working. It's not really necessary, but hey, it's a TDE workshop. So we do a set key on our container database. On our pluggable database, we do a set key on the container, on the root container. Okay, and again, the DBAs do not know the OKV password, and they don't need to know it. So the next part is, what am I doing next? Okay, all right, so I copy, I will be executing a few, the The RESTful API in Key Vault 18 has been enhanced to not only do the deployment part of the OKV client integration with OKV for the database, it also allows you to create keys, create wallets, and do all these things. And with the old configuration file, we didn't leverage the cluster functionality of OKV. We downloaded the script and we just connected to the OKV server with the IP address 18.1, right? But I have a 2-node OKV cluster and we never talked, I mean, the keys are replicated, everything is there, but we never talked to the second OKV client. So now I added from the original configuration file, I added the user and the client wallet entry into our configuration file. If we use okvclient.ora as a configuration file, we can leverage unique commands. We can do KMIP operations in OKV. So to do this, so if you can you scroll back for a moment? Mm-hmm. Here I create a wallet, a unique wallet, where OKV verifies that the wallet name doesn't exist, a unique wallet, and this wallet name is move FinPDB keys. So I want to move my PDB from that one container to another container. And luckily, because I tagged my PDB keys, I know exactly which keys will be copied into this wallet in OKV. So first I created this wallet, and the second command is I check the object status to see if my wallet is ready. So for now it's pending. I do this 2-3 more times. And then it's active. And then I can give my endpoint read-only access to that unique wallet, right? You see that underscore OKB01 was added to the OKV name, to the wallet name. That's because we do a unique wallet. And so now we have, now our endpoint, David122 on David, has read-only access to the wallet. So now we go into OKV and we find our move FinPDB wallet. We edit this wallet, and maybe I have to move that window out of the place. We add items. And now we search for the keys that belong to our FinPDB. So for this, we need to display all so that we have all our keys. Sort by date, and then I look for tags that contain FinPDB. Okay, so here we go. I've done this exercise a little bit more than only once, so you see many FinPDBs, but I will copy only those keys that we have from after migrating. So those 4 keys are in this wallet, right, in the move FinPDB keys. And now I can download OKV util download. I can use the OKV download command, OKV util download, exactly, minus type is wallet, minus G is my wallet name, and I copy this wallet into the temp directory, the new wallet password, and the OKB endpoint password. And I didn't specify the right wallet name.
And I think that's the end of our video here.
Ouch. Okay, so if you, can you make that big again? It's small now.
Yeah, let me,
Okay, so what we were, oh, it's on, it went back to the beginning. So this part is, yeah, so what I did, what you can see here, I specified the wrong wallet name. So it should be move PDB keys underscore OKV01.
Mm-hmm.
And that is why that command failed.
Mm-hmm.
I sincerely apologize, but hey, that's the demo effect. What I would have done is I would download that wallet into the temp directory and then afterwards do an mkstore -list to show that only 4 keys are in that wallet, only the keys that belong to that PDB. So if I want to move that PDB to another container, I unplug the PDB, plug it into the other container, and copy that wallet physically over to the other server, maybe upload that wallet into another OKV, and then my PDB will find the correct keys immediately.
Yeah. And Peter, I think what was really important here is, hey, you have to know that Key Vault endpoint password, right?
Yes.
So the database administrator doesn't know that, so he can't download those keys and take them to a separate environment. So you've really created a fantastic separation of duty here, separate responsibility between what the database administrators can do and what your security team can do. Okay.
Yes, exactly.
Yeah. So I'm going to go back to the slides here, and we're just going to kind of wrap this up because we ran over a little bit, but I think it was worth running over for, so we just let it run. So again, here was our scenario today. We set up that wallet-based TDE. We encrypted the existing tables. Oh, actually, we created a table space and encrypted it.
Mm-hmm.
We switched roles, did ReKey operations, tagged those PDB clients to know what master keys were associated with the CDB, the PDB, and at which point in time. Peter showed us that installing the OKV client software via REST API, which I think is fantastic for enterprise customers. And then again, going through that migration, uploading, and getting rid of those local wallet files. So, and then we got ready for that next step. So we can do another demonstration on, relocating that pluggable database. So if you guys, for those of you who hung with us as we're 10 past the hour, please put in the chat, what would you like Peter to demonstrate next time on TDE, right? What is it that that you want to see? Do you want to see Data Guard on 19C? Do you want to see RAC on 12.2? So just kind of give us some feedback if you get a chance, and let us know what we're going to be doing or what you want to see for next month or next time we do this. So
yeah, and Rich, there's one more thing that I would like to highlight. So that targeted download of a wallet, you cannot do this with an HSM. That's another thing where OKB is basically specifically created in the functionality to support all the things that you can do with a database. Right? The HSM vendors, yes, the keys are very secure, but they are not flexible enough to support all the things that you can do with your database. And OKB is fully integrated into those advanced use cases. Right? That's a very important fact.
Yeah, absolutely. I'm glad you pointed that out. All right, so our next office hours are going to be in February. I think it's the 13th, not the 14th. So I got that date wrong. But let's open it up to some questions here. So like Russ said in the chat, if you have any questions, you can enter them in the chat. At this point, if you'd like to unmute yourself and ask Peter a question, you're free to do that as well. Rowan asks, can you have this recorded version? Yeah, absolutely. We are going to publish this at asktom.oracle.com. So it'll take us a few days to edit this, and we've got another session today, and we'll incorporate the Q&A from that. But yeah, absolutely. We'll put this up there on asktom.oracle.com so you can watch and study this later.
Yeah, I was wondering about the performance regarding compared to other tools. I mean, other vendors' tools. Do we have any benchmarks?
You mean which tools? You mean TDE?
For the encryption keys. I mean, Key Vault.
Performance for Key Vault. One of the biggest benefits of OKV is that it's a soft appliance. You can install it on any size hardware, and if you run out of steam, if you instead of 500 databases now you have 1500, you need more power in your OKV servers. You can either add more OKVs OKV 18 allows up to 16 OKVs to be clustered together. Or you can scale vertically by putting OKV on larger servers.
Okay.
So that's another point where we are way more flexible than an HSM, where you have a fixed amount of CPU power, a fixed hard drive, a fixed everything, and when you run out of steam, you just have to buy a new one, and those are very expensive.
Okay, can the appliance be running on a virtual environment?
Yes. Yes, you can.
Great questions.
Okay, thank you.
Yeah, thanks for joining us.